we will study what do you mean by path and the process. Any change a system undergoes from one equilibrium state to another equilibrium state, it is known as process. A series of states through which the system passes during the process, it is known as path of the process. You can see here, I will call this as a property A, I will call this as the property B. The system is at state 1. In the previous slide we have shown the example. The system, it was having mass 2 kg, temperature 25 degrees centigrade, volume was 1 meter cube. So in the next state what we have shown, volume is 3 meter cube. That means a series of states through which the system passes during a process, it is known as path of the process. It is one path. So process means any change that a system undergoes from one equilibrium state. So here the system is at one equilibrium state. It is changing from one equilibrium state to another equilibrium state. Then this process, whatever it is going to change from state 1 to state 2, we are calling it as one process. And the series of states through which a system passes during this process, it is known as the path of the process. You can see here the gas continuously here, the gas is contained in a piston cylinder arrangement. So initially the gas was here at state 1, it was having some volume 3 meter cube, mass was 2 kg, temperature was 25 degrees centigrade. Here the gas is compressed, that means volume has decreased from 3 meter cube to 1 meter cube. Here you can see here, that means the system has changed to a different state. So whatever the series of states through which a system is passing, we are calling it as the path of the process. This is my path from state 1 to state 2, it is moving. So this is my path of the process, and this is my process from state 1 to state 2, it is moving, means it is my process. To describe a process completely, so here one should specify, or we should specify, the initial and the final states as well as the path it follows. Then only we can describe the process completely. If there is no any initial state and final state, how we will describe the process if it is not having any path also? So here path means it is moving from either from state 1 to state 2 or from state 2 to state 1, and its interaction with the surroundings. Then only we can describe the process completely. So next we'll study what do you mean by this process. So here we are going to study quasi-static process. It is also called as the quasi-equilibrium process. When a process proceeds in such a manner that the system remains infinitesimally close to an equilibrium state or equilibrium conditions at all the times, it is known as quasi-static or quasi-equilibrium process. So quasi-equilibrium process means it is a very slow compression process, or it is a very slow expansion process. Quasi-static means it should be a very slow process. Either it may be a compression or either it may be a expansion. So when the process proceeds very slowly, then at all the times the system is going to remain in an equilibrium state at all the times. See here, at a time t equal to 0. So after some 5 minutes at t equal to t1, if I will measure the properties of this system, so we are going to get the system, it will be in equilibrium. So equilibrium means don't be under the impression that here initially the volume was some 5 meter cube. So when the process is compressed, here volume is some 3 meter cube. But at this state, at t equal to t1, all the properties are uniform here. Temperature here also it is same, here also it is same. Pressure here also it is same, here also it is same. Volume also same. That means at each and every time it remains close to an equilibrium conditions at all the times. Suppose Now, if this in the piston and the cylinder arrangement here gas is there. So if this gas is compressed suddenly, the whatever the molecules which are present in front of the piston here, when the gas is compressed suddenly, these molecules, gas molecules, they will not have enough time to redistribute themselves inside the container of the inside this container or inside the cylinder portion. So if this gas is compressed very suddenly, then these gas molecules, they will not have enough time to escape themselves or to redistribute or reorder or rearrange themselves. When it is compressed suddenly, the molecules, they will get pile up in front, in a small region in front of the piston, so thus creating a very high pressure near the face of the piston rather than the other side of the cylinder. So here pressure will be very less, here the pressure will be more because of the sudden compression. These gas molecules, they will not have enough time to escape, so they will get pile up in a region, in a small region in front of this pressure, piston. So here pressure is going to be created more here in front of the piston in this area. So now we'll tell that the system is not in an equilibrium state, because pressure here is less, here pressure is more. So where pressure is more, definitely here temperature will be also more, then the system remains in, it is not remaining in a thermal equilibrium. Then we are going to call it as non quasi static process or a non quasi equilibrium process. See here, it is a very slow compression, slowly we are compressing here. In non quasi static, suddenly the gas is compressed here, so the system does not remains, it is a very fast compression process or a very fast expansion process. So here it is called as the non quasi static process. You can see here process path. So from state 1 to state 2, it is shown by the continuous lines, and non quasi static process, it is denoted by the dashed lines. Here you can see here for pressure and volume.